This video, we're going to talk about the limit comparison test. And this is pretty much a very useful test, but it involves a lot of what we call a p-series. And actually, p-series is actually a determined factor with these tests. Okay, so basic idea is that we take the limit as n approaches positive infinity of a n over bn, where that is equal to some constant c, and that is less than infinity, then a n or bn can both converge or diverge. Now, here's the idea. We're going to go based off Bn. And the idea is that if Bn converges, then the series of An and Bn converges. Okay, that's the idea. And if Bn diverges, then we could say the series also diverges. Well, what is Bn? This happens to be a p-series. Okay, and we're going to talk about how to determine that. So let's look at a couple examples. So what if we're given this series here where we have k is equal to 1 to positive infinity of 1 over 9 k squared plus 6. Okay, you want to use the limit comparison test to determine does it converge or diverge. Well, to me, it looks as if my an, well, what is my an? My an is my original function. Okay, my an is my original function. Okay, now bn is the p-series, and how we get bn is that we take the highest term with the highest coefficient on both the top and the bottom. So in this case, the highest term with the highest coefficient is 1 on the top. The highest term with the highest power is actually k squared. Okay, so this is actually k squared. So if I look at this, I'm going to take a limit as n approaches positive infinity of 1 over 9 k squared plus 6. I'm going to simply divide that by, I'm going to simply divide this by the highest, the term that contains my highest power on both the top and the bottom. So if I look on the top, I only have a 1. If I look on the bottom, I have k squared. Okay, and so the idea is that this is my an, this is my bn. Okay, and so if we're dividing fractions, remember we could flip it and multiply. So this becomes as n, limit as n approaches positive infinity of 1 over 9k squared plus 6. We're going to multiply that by k squared over 1. Okay, so you could see that our limit as n approaches positive infinity now becomes k squared over 9k squared plus 6. And obviously we could get the limit. We know the limit for this is actually 1/9, but that doesn't tell us anything. What we need to know is that this is a p-series. And so the general idea is that the summation from k is equal to 1 to positive infinity of 1 over k squared. Well, what's my p here? My p is 2. Okay, and remember we said that if p is actually greater than, if p is greater than 1, so in this case p is equal to 2 and 2 is greater than 1, then we say the series actually converges. And so the idea is that if this p series, or if bn converges, therefore we can conclude that the series from k is equal to 1 to positive infinity of 1 over 9k squared plus 6 also converges. Okay, so that's the idea. So let's take a look at one more. Okay, so what if we're given this one, where n is equal to 1 to positive infinity of 1 over n plus 2 n plus 3. Okay, we want to determine if it converges or diverges using the limit comparison test. Well, to me, it looks as if I could distribute this back into a polynomial, and the reason I like doing that is here's why. Okay, so if I distribute this back into a polynomial, this is equal to the one that I'm about to write. This is 1 over, what is this? The first term is going to be n squared. Second term, 2 plus 5, so that 2 plus 3, that would be 5n, plus 2 times 3 is 6. So this is a series, okay? And the idea is that now I could take a limit as n approaches positive infinity of 1 over n squared plus 5n plus 6. And so this is my an. Well, what is my bn? Well, it looks as if I have a 1 on the top. I'm just going to multiply it simultaneously. So if I flip, I get a 1 on the bottom. And it looks as if I have a n squared, which is my highest term. So this would be n squared. And guys, this is the same thing as dividing by 1 over n squared. I just did it all in one step. And so if I look at this, this now becomes the limit as n approaches positive infinity of n squared over n squared plus 5n plus 6. Okay, we know the limit for this is actually 1. Okay, but what is the idea we want to get away from this? Well, what is my bn? My bn is actually from n approaches 1 to positive infinity of 1 over n squared. And again, you could see that here, this is a p-series where p is equal to 2, and that is strictly greater than 1. So therefore, this converges. And so if this converges, therefore we can conclude that the series of n is equal to 1 to positive infinity of 1 over n plus 2 times n plus 3 also converges. So this is a general idea behind the limit comparison test. We're using the p-series as the deciding factor. We're using the p-series as a deciding factor to determine whether the series converges or diverges, okay? And so let's look at another one. So let's see. So what if we're given this, where we have k is equal to 1, positive infinity of the square root of k over k cubed plus 1. Okay, we want to use the limit comparison test to determine whether the series converges or diverges. Well, to me, remember we take the highest term with their the highest power on both the denominator and the numerator. And so if I look at this, I'm going to take a limit as n approaches positive infinity of square root of k over k cubed plus 1. I'm going to divide in this again. This is my an. Okay. Well, what is my bn? Well, it's the ratio of the highest terms. And so if I look at this, this is the square root of k over k cubed. Okay. Now I could rewrite this as the limit as n approaches positive infinity of the square root of k over k cubed plus 1. I'm going to multiply that by square root of k on the bottom. Okay, you get a flip, and this becomes k cubed. Okay, and so you can definitely see that these will cancel out. And so my limit as n approaches positive infinity will now becomes k cubed over k cubed plus 1. And we know this limit is equal to 1, but do we care about that? No, what we care about is there's a p-series that we could use. And so if I'm looking at this, well, this is, bn is k to the 1/2 divided by k cubed. Okay, and so to get this into a p-series form, if I bring down this becomes 1 over k to the 3 times k to the negative 1/2. Okay, and so if we have the same base, all we do is add the exponents. And so this p-series is actually 1 over k to the 5/2. So if I subtract 3 from 1/2, I get 5 halves. Okay, 5 halves is around roughly 2.5. Okay, and so in this case, we know that p is actually greater than 1. Okay, because p is actually 5 halves. So therefore, we can conclude that the series actually converges. So if the p-series converges, therefore we conclude that we can conclude now that the series where k is equal to 1 to infinity of the square root of k over k cubed plus 1, this also converges. And so that's the general just behind the limit comparison test. We're taking the original function and we're taking the ratio in a p-series form, okay, and we're dividing the two, and essentially if the p-series converge or diverge, then the series actually converge or diverge. And that is a general gist behind, you know, the limit comparison test.